All right, and 7, which is our last question here, we're asked, is there a limit to the number of wavelengths emitted by a certain element? If so, what's it due to? If not, why not? So here's the situation that we have. So for a hydrogen atom, we have a single electron. For the stable hydrogen atom in its ground state, we have a single electron in the ground state in the n equals 1 level. And then we have these empty levels, and we have an infinite number of these. So the values for n go from 1 all the way to infinity. So any integer, any counting number from 1 to infinity. So if I take this and I hit it with light, I can put this electron in this level, this level, this level, and any of the infinite number of levels that I have up through there. And then when it decays back, it will emit some light. Okay, so I can cook this. So heat it is one way of doing it. Heat it extremely hot, and I could have this electron go into the, I'll just pick one, n equals 4 level. And then how does this get back to where it was? Because it definitely wants to. It wants to get back into the n equals 1 level. Well, it does that by releasing light. Okay, could be visible light that you and I could see, could be UV, could be gamma rays, it could be any part of the electromagnetic spectrum. But there's an unlimited number of wavelengths that it can have because there's an unlimited number of excited states that we could put that atom into, and then it could decay from any of those excited states back to the ground state. Or it can even decay not all the way to the ground state. The electron could decide it just would be happier in for a certain time to drop down to the n equals 3 or the n equals 2. But it will fall, release some amount of light, and then, so there's an unlimited